Hi everyone, welcome to Anu's classroom. In this video, we are continuing with our discussion on MMPC 5's important questions and answers that have been asked in the previous years. So this is the third part of this and what you can say discussion. The last part we had discussed all the few different types of practical questions or the mathematical questions that have come up in the previous years. This video will be discussing solely all the theory questions that have come up. So let's get started. So the first question in this video is, what do you understand by the terms primary data and secondary data? Explain some of the points to be kept in mind while designing a questionnaire. So this is from unit number 1, the very first unit, right? So what is primary data? It is the primary, that is the first hand data that is collected or gathered by the researcher. Okay, secondary, second. So it is the second hand data, right? It is the data that is collected by somebody else earlier for their research and we are reusing it for our purpose. Now there are different methods of collecting data. We can do interviews, we can do surveys, we can use questionnaires, all sorts of things. Now in this question, they are asking us some of the important points that we have to keep in mind while we are designing a questionnaire, right? While we are designing a questionnaire, there should be a preface as to telling the user or the person who is going to answer your questions regarding why you have prepared this questionnaire, what is the aim of this data collected, and then assure them that the questionnaire, all your responses will be kept confidential and all such things. Any footnotes and all you have to include, right? A good questionnaire, it should be valid, it should be clear, second, interesting. When we should make sure that before we are releasing the questionnaire, we should scrutinize each question for clarity, and the questions should be based on a clear conceptual framework. So those are some of the important points. Next is, describe the concept and significance of the measures of central tendency, define quantiles, discuss how you would compute the several quantiles such as quartiles, dectiles, percentiles and all. So again, we had created a detailed video regarding these measures of central tendency as well. This I guess it comes, I think, in unit 3. Anyway, these are all from block 1 itself. So what is a measure of central tendency? It is a summary measure, the measures of central tendency, that is mean, median, mode. Remember that. It is a summary measure which attempts to describe the whole data set with a single value, that is representation of the entire data set, right? It represents the middle or the center of this distribution. Now, what are quantiles? Quantiles, you can think of them as cut points which divide the range of probability distribution into continuous intervals with equal probabilities. Like if it is a quantile, okay, if it is a quartile, quart means 4, right? If this is your normal distribution will be divided into 4 equal parts by a quartile. Deciles, 10, it will be divided into 10 parts. Percentiles, cent, 100, it will be divided into 100 equal parts. Okay, now the formula for computation and all I've given in detail in the explainer video. I'll leave a link to it. Okay, please check it out. Next is, explain arithmetic mean along with its properties. Also explain the relationship among the mean, median, mode with the help of a diagram. Again, we have a detailed video for this concept itself in our MMPC 4 series. Okay, so better, since a lot of questions we have already covered, especially from the unit 1 and 2 we have covered. I will leave a link to the MMPC 4's playlist. Okay, you guys can go and check the playlist and pick up the videos which you want. Okay. So what is mean? It is a number that is obtained by dividing, right? Dividing the sum of values of the data set by the total number of values. We all know mean is nothing but the average, right? So what is the relationship between mean, median and mode? It is that your mode will be equal to 3 times the median minus 2 times mode. Okay. Sorry, mean. My mistake. Okay. Mode is equal to 3 times median minus 2 times mean. Okay, sum of the properties of mean. So what are the properties? Sum of the deviation from mean will be 0. Sum of the square deviations from the arithmetic mean will be minimum. Like that you can write down the few properties. Again, it is covered in unit number 3. Okay. Just a gentle reminder, I know most of you would have already subscribed. If not, consider subscribing to the channel if you like this video or the type of contents we are making. And make sure you press the bell icon so that you do not miss any updates. We will be posting videos for the remaining upcoming exams as well. Okay. So consider it if you like it and share it with your friends as well so that they will also be able to score good marks in the upcoming exams. Alright. So let's move forward. The next question is, discuss the applications of quantitative techniques in various functional areas of management. So what are the few ways in which quantitative techniques can be applied, especially when in order to manage? This is a very important question for us, right? As future business administrators, as people who are planning on actually managing businesses, this is a very important question because we should know why we are studying this subject, right? So what are the few reasons why or how we can make use of quantitative techniques in our management? Business owners, we can use the quantitative methods to predict the trends or determine the allocation of resources, manage our projects, evaluate instruments, determine the best assets that we can invest in, or the best time to do so. All those things we can do if we know quantitative techniques, right? If we know the sales data of the past 1 year, we will know the peaks of when people will be coming into the store more often, especially festive seasons, Diwali, Eid, Christmas, New Year, or maybe weddings. So those seasons we should be making sure that there is good ample enough stock, new models, all those things, right? If we are doing a textile business, or if we are into share market, we need to know, we need to be aware of the bullish trends, the bearish trends. Maybe we can look at the candle charts and analyze, or maybe look at the trends in the industry so far. Like during COVID, it might have been a very good time to invest in pharma stocks because that was high, it was soaring, right? So like that, all these things we can do with the help of quantitative techniques. Next, standard deviation is the most widely used and important measure of variation. Comment on the statement. Also discuss the properties of a good measure of variation. This also is in block 1, I guess unit 4 or so. Okay. Just check it out. There is a unit specifically for these deviation, variances, the different types of variances. Okay, not just standard deviation, but variations in mean, median, mode, the quartile deviations, all those things are given. So in that, this answer to this you will find. Okay. So next question, what do you mean or understand by the term classification of data? What is the main reason for classifying data? Also explain some of the common types of classification. Okay, what is classification of data? Simply put, it is arranging. Classify means arrange, right? Arranging data. It is the process of analyzing structured or unstructured data and organizing it into categories based on type, contents, all those things, right? There are what are the main reasons for classifying data? Well, systematic classification of data, what all things it will help us in? It will help us organize or track, manipulate, analyze all the individual pieces of data, right? It will help us condense data, facilitate data preparation, highlight the important or significant features of data. It will help in comparisons. All those things are reasons, good enough reasons to classify data, right? We have ample reasons for it. Explain some of the common types of classification. So we can have very many different types of classifications of data is possible based on the context, right? So if it is a document that we are trying to classify, we can classify it as confidential, internal, private, protected, public, all such sorts of classification. But in general, when we are talking about is, no, that is based on the quality of the data, right? But over here we should be more concentrating on the what you can say, the quantitative techniques, right? So based on geography, okay, geographical data, based on chronology, that is timeline, okay, chronologically, then again based on the quality of the data, that is qualitative, then based on the quantity, quantitative techniques can be used to classify data. So all these things again, I guess, comes under your unit 1 itself. Anyway, these are all belong, these all these questions they we have discussed so far, they all belong to unit 1, block 1 itself. Okay. Okay, next again, what is mode and modal class? State the equation for obtaining mode from grouped data. What do the various elements in the equation for mode signify? Give some merits and demerits. So mode and modal class and all also we have done a detailed video. Please check it out. But still, we'll just quickly touch on the important points anyway. So what is mode? It is the value that occurs the maximum, right? The most often occurring value in the data set, that is your mode. What is modal class? The class, okay, if it is in a continuous frequency distribution, then the class which has the highest frequency, that is the class interval within which, within the data set that contains the most number of data points. That is what I said, highest frequency is your modal class. Okay, what is the equation for mode? It is the lower limit of the modal class plus d1, that is difference between the frequency of your modal class, okay, minus and the preceding class, divided by d1 plus d2. d2 is the difference between the frequency of your model class and the succeeding class, multiplied by the class interval. You will get the equation, we will get the value of mode from grouped data. Okay, so those are the different elements as well. Now what are some of the merits and demerits of mode? So what are the merits? It will not be affected by extreme values. It can be found graphically as well. It will always be present in the data set. Now, when we think about median or mode, the calculation, the amount, the value which we get may not exactly be present in the data set, right? As a single individual value, it may or may not be present, but mode, it will definitely be present. And it is absolutely not necessary to know the length of the open-ended classes also in order to find the mode, correct? It is the very simple form of one of the most simplest forms of measures of central tendency. Few demerits of mode, again, it can't be determined if the data set is multi-modal. There are data sets where there are more than one value which occurs the equal number of times, and that is the highest number of times a value has occurred also, right? So those such data sets are multi-modal. So we cannot pinpoint that this one type of mode itself only will be there. Then it is based upon the concentration of values, okay? And so therefore what happens is that the outliers and all are not included in the classification, correct? It is there, and also it is therefore very much fluctuated by sampling. Definitely we know that when we are actually doing a quantitative analysis, we will not be doing the entire thing on a we will not be doing it on the complete population, okay? We will have training models, we'll have softwares. Actually in business we have a lot of softwares. We have few of them are like Data Equus, there Alteryx is there, Power BI, Tableau, ThoughtSpot, all these softwares are there which will help us do these data analysis part and all. So over there we will take a sample, we will create training and testing data sets, and then we'll train it and then test the data set, and that is how we do, and then finally we'll remove the sampling. Okay, so now what happens is that the mode, especially when we are doing this training models and testing and all this, in this, the sample that we take, okay, that sample, the initial sample we take to do these things will affect our mode very much, okay? And it is definitely not capable of any further algebraic treatment as well. Just by finding the mode, we can only know that this is a maybe this is the month, that if we are talking about sales data, we might know based on the sample maybe that this month or this particular date we had highest sale. But apart from that, mathematically speaking, we will not be taking this mode value and substituting it in any of the further mathematical calculations. It is generally used for inferring business decisions or understandings of the trends and seasonal variations and stuff, okay? So that is about mode, okay? Then short note on mathematical properties of median. Again, this you can find it in the unit. I'm not going, it's clearly mentioned, I'm not in the textbook, I'm not going into it again. Okay, what is more than type ogive? Again, this is there in the textbook, okay? It is a graph where the graph will the frequency graph, when plotted, it will have such a pattern. Why? Because the what you can say, the frequencies of the subsequent or succeeding classes, they are added to the previous classes in order to find this graph. That is more than type ogive. Again, mathematical properties of mean also, it is clearly mentioned in the textbook, not going into it again. Guidelines for choosing classes also clearly mentioned in the textbook in the block 1 units, not going into it again. What is standard deviation and standard error? So standard deviation, we all know, it is the measure of what you can say, variation, right? It is a measure that shows how much variation or spread is, how much the data is spread across from the mean, okay? And what is standard error? It is a statistical term that measures the accuracy with which a sample distribution represents a population by using standard deviation, that is standard error, okay? So moving forward, what are long-term decisions? What are the various methods that are used in forecasting of long-term decisions? Okay, what are long-term decisions? Decisions that are what you can say, made with what you can say, many years or decades ahead, right? Focusing on what we will be doing, how the track we will be taking, or based on our long-term visions or missions, that is long-term decisions. Now, what are the various methods used in long-term forecasting? A few methods include the straight line forecasting, moving averages, simple regression, okay, multiple linear regression. All these things are methods used in forecasting long-term decisions. Primary purpose of forecasting is to provide valuable information for planning the design and operation of enterprise. Planning decisions may be long-term, medium-term, short-term. In view of the statement, they are asking us to explain the application of forecasting for long-term decisions. So why do we use forecasting? It is used to help make informed business decisions, right? So applications of forecasting for long-term decisions include recognizing the future issues, identify opportunities, make strategies to pursue the management objectives, better production management, improved cash flow, effective hiring. So with all these things, the main point is that, like with long-term planning or long-term decision making, the approaches or the what you can say, the path we take, okay, might differ from if our focus was on short term decisions. That is, with long term in mind, sometimes we will deviate from our otherwise normal way of acting, right? So if suppose, like for example, you have a long term goal, okay, you are getting a salary of, let's say, 25,000 per month, okay, and if you have a goal of, say, a long term goal of maybe like in a 10 years you need to buy a flat, okay, if that goal was there, if that long term decision was not there, then the way you spend your 25k today will be different from the way you spend 25k with that aim or that goal in mind, right? So that is long term decisions and forecasting for all those things, okay. So let us move ahead. Next question is, what are the various key issues in decision theory? Explain the decision tree approach. Again, on the same note, we have write short note on decision tree approach. Okay, so these type of questions we have had coming up multiple times, okay, in the examination, more than the questions we have discussed so far. So about decision tree, it has come up quite few often, okay. Same is the case with standard deviation, mean, median, mode and stuff, okay. So all those concepts at least once we have seen in question papers. So decision tree again is one such important point to stress on. So let us look at decision trees. So a decision tree, they are commonly used in operations research to help identify a strategy that is most likely to reach what you can say, reach the goal, okay, as well as it is also used in machine learning also. So how we do is that there will be a complex problem, we will be splitting that big problem or that entire thing into smaller branches, okay. So and we will plot them all, okay. Maybe this is a starting point. Let us assume, say you want to make a pen, okay, simple example, you want to create a pen. Now what are the few decisions that you might have to take? Whether you should uh, create an ink pen, okay, or maybe you have to create a gel pen, maybe you want to create a ballpoint pen. And now if you are using an ink pen, then what you can say, should it have a flexible nib, should it have a fixed nib, okay, how much or if you're using a ball pen, then what should be the shape of the pen, what should be the size of the pen, how what should be the diameter of the of it, right? Should it be 0.7 mm, should it be 0.5 mm, right? How or if it is a gel pen, should it also be waterproof, okay. Things like that, right? So this entire big decision you are making into small branches, and we will assign or we will evaluate each of this and find out the risk or all those things, all the probabilities as related to each of these branches. And then finally we will pick the best branch or the best course of action from the whole of it, okay. So that is decision tree approach, okay. Now yeah, so as I was saying, it involves making a tree shaped diagram to chart out the course of action or the statistical probability analysis, and it can help us in breaking down the complex problems into smaller branches where each branch could become a possible outcome, right? It will divide the entire big problem into manageable parts, you can say. What are the few advantages? It will help in comprehensive analysis of each course of action. It is very easy to validate. There will be good amount of accountability as well. Some of the issues or the problems, the key issues in decision theory include, it is very unstable. It is very less effective in predicting outcomes, especially if the variables are continuous. Now, the reason why we were able to properly chart the pen is it is kind of like a discrete one, right? Either it is an ink pen or it is a ball pen, it is a gel pen. So these are discrete variables. But if it is continuous variables, we will be hard pressed to find to create a decision tree like this. Okay, so that is one of the major issues in decision theory as well. Computational efficiency, it is prone to sampling errors also, okay. So those are some of the key issues. Moving on, again related to hypothesis testing also, we have had these two questions repeating multiple times in previous year's question papers, okay. That is, what do you understand by the term hypothesis? Explain null and alternate hypothesis along with help of examples. And also we have had questions regarding write short note on hypothesis testing procedure. Okay, so what is hypothesis? It is just, in short, you can think of it as assumptions. Okay, hypothesis is nothing but the assumptions that are made based on the observations. Okay, so what is null hypothesis? It is the type of statistical hypothesis that proposes that no statistical significance exists in a given set of observation. Okay, you can think of it, and it is represented generally as H0. Alternate hypothesis is the absolute contrary or the opposite of this null hypothesis. We can either represent it as H1 or also as HA. Okay, like for example, null hypothesis might be like, if in the event of you taking a lottery, the null hypothesis you will be claiming is that I am going to win up to, that is, I am going to win an amount that is less than 1000 rupees in the lottery. Alternate hypothesis will be that you will be going to win, or I am going to win 1000 rupees or more. Okay, and basically what we will do is we will look whether there is enough change or enough chance to be able to reject the null hypothesis and accept the alternate hypothesis. That is what our sole aim is. Okay, so yeah, next is hypothesis testing procedure. So there are 5 steps in the hypothesis testing procedure. Okay, first step is we have to state our null and alternate hypothesis. Then we will collect the data. After that we will perform the test. Okay, that is the statistical test. Then we will decide whether we have to accept or decide our null hypothesis, and we will present our findings. Okay, so that is the hypothesis testing procedure. Next, what is the major difference between probability and non-probability sampling? Briefly outline sampling methods that are covered under probability and non-probability sampling. Again, on the similar lines, what do you understand by probability sampling methods? Again asked. Explain the various types of probability sampling. We have had short note on non-probability sampling methods as well as probability sampling methods. So as you might have understood by now, this section, that is probability and non-probability sampling, that is also important. This is entirely one unit in your textbook, that is titled sampling. Okay, sampling methods also. So you should definitely read that before your exams. Okay, so let us look at what is probability sampling and non-probability sampling. And okay, so probability sampling is nothing but a decision whether a particular element is included in the sample. Okay, or whether that element is included in the sample or not will be governed by probability or chance. Okay, non-probability sampling, right opposite. There is absolutely no what you can say, involvement of any kind of chance in deciding whether or not the sample would be included in the the element would be included in the sample or not. Some of the few what you can say methods. Okay, probability sampling method, we have what are simple random sampling, then we have systematic sampling, we have stratified sampling, and we have cluster sampling. Now, we have had short notes regarding on what you can say, systematic sampling, stratified sampling, cluster sampling. What is the difference between cluster and stratified sampling? All such sorts of questions also have come up in the past. So this unit, do not skip, I would say. Okay. Similarly, non-probability sampling methods, they are convenience sampling. Then we have purposive sampling. Okay, we have judgment sampling, quota sampling. Okay, so these are the different types of non-probability sampling methods. So yeah, as I was saying, right, stratification, cluster sampling, stratified versus cluster, systematic, stratified, all these different types of questions have come up from that unit. So what is stratification? Stratification is nothing but the act of sorting, right? Stratification is sorting data into different layers, you can say. Okay, different layers or distinct layers. So what will be stratified sampling? It is a type of sampling method which is in which the total population, the entire population, it will be divided into multiple smaller groups or strata to complete the sampling process. Okay, and these strata are formed based on some common characteristics in the population. Okay, like the strata could be if the population we are trying to divide on the basis of age, means maybe infants, okay, toddlers, adolescents, what do you say, youth, old, seniors. Okay, like that maybe you can divide. So based on any particular characteristic, we stratify the entire population into different strata. Okay, stratify, strata, that is what you have to keep in mind. Okay, similarly, cluster sampling, what we will do is we will divide the entire population into different clusters. Okay, so like for example, this districts that we have in our states or schools, okay, they are all different clusters, and when we do the sampling, what we do is we take the one cluster or a few clusters from all the clusters of the entire population, and then those clusters will be completely taken. Okay, all the sample from that particular cluster will come up, all the elements from that particular cluster will be used for our sample. Okay, whereas in stratified sampling, what actually happens is that few elements only, but from all the levels will be taken up. Okay, like a few people from who are infants, a few people who are toddlers, a few people who are between the ages of 10 to 15, a few people who are between the ages of 25 to 30, few people who are above 60, like that. From all the different levels we will take. But whereas for cluster sampling, all the people in that district will be taken. So that is the difference. Okay. Then what is systematic sampling? It is where researchers will select members of the population at regular intervals. Like you might have noticed when you are in school and all, your teacher would ask you to uh, tell numbers, right? 1, 2, 3, 4, and then again it will start 1, 2, 3, 4, and then they will say, okay, all the people who said 4 is one group, all the people who said 2 is one group. Okay. So what actually happening over here is that at regular intervals, whoever is occurring, they will all be taken together, like maybe the every fifth element or the every fifth person in the line. Okay, something like that. That is systematic sampling. So I hope these different types of sampling methods is clear to you. Yeah, which one is preferred in what circumstance? Okay, suppose say the researcher wants to select what you can say, the researcher wants to know about each subgroup of the population that is being studied. Okay, like for example, if the researcher is trying to do a research on how different age groups differ in their attitude towards religion, then that person should better go for stratified sampling. Okay, but at the same time, we have to study a very large population that is spread out. Okay, like for an example, the entire state data we have to consider. In that case, it will be much better to study using cluster sampling. Okay, so that is how we prefer which sampling method to be preferred. That is how we choose. Okay, let's move on to the next question. Okay, what do you mean by probability? What are the different approaches to probability theory? What is chi-square distribution? So these are again type of questions which have come across multiple places. So what do you mean by probability? It is the measure of the likelihood, like likelihood that event might happen. Okay, what are the different approaches to probability theory? We have two approaches mainly, that is classical and relative frequency approach. Both these approaches and entire definition of all detail about probability, we have already created a detailed video on it. Kindly go check it out. Okay, it will be there in our MMPC 5's playlist. Okay, what is chi-square test? Chi-square distribution. We have had short note question as well as essay question. So chi-square distribution, again chi-square distribution also, there is one entire unit dedicated to it. Chi-square distribution, please read it. It is a continuous distribution with a degree of freedom, and it's used to describe the distribution of a sum of squared random variables. And this chi-squared goodness of fit test is a statistical hypothesis test that is used to determine whether a variable is likely to come from a specified distribution or not. It is used to evaluate whether a sample data is representative of the full population or not. Okay, whether the sample data is a good fit of the entire population. That is what we are trying to find out. Okay, and how chi-square distribution is used in the testing of independence of categorized data is actually what actually we do with the test of independence is that we are trying to check whether two variables are likely to be related or not. Okay, so we'll have the counts of those categorical or those nominal variables, and we might have an idea of whether those two variables would be related or not. Okay, but the test, using the test, it will give us a way to decide whether the idea that we had was actually reasonable or plausible or not. Okay, so that is chi-square distribution, the goodness of fit, and testing of independence. So the same thing you can repeat if you are asked to write a short note on the chi-square distribution. Moving on. Again, this is also multiple times it has come up, time series analysis. This is also one entire unit dedicated to this time series analysis. What do you mean by time series analysis? How would you conduct this analysis for forecasting sales of a product? Same way, time series analysis, they have given a quote and they are asked to comment on the statement. And they've also asked to explain the decomposition method. Okay, we'll come to the decomposition method part. Again, short note on time series analysis. So let us look at it. So this time series analysis, it actually helps us to see what factors influence certain variables from period to period. Okay. And so like for example, the value of retail sales each month over a year, how it happens. That is time series analysis. This decomposition method, to forecast using decomposition model, actually what we do is we calculate the future values for each of the separate components. Like decomposition, the word itself means that we are trying to break down this entire big problem or this entire big analysis into smaller ones, and we will solve each of those separately. Okay, we can solve them either in parallel or in sequential. Okay, and what we will do is that we will calculate the future value of each of these separate components, and then we will add them all back together. That is, we'll sum them all up to obtain the prediction. That is how we do decomposition method. Okay, so it is this time series analysis itself, it is a specific way of analyzing a sequence of data points that are collected over an interval of time, right? Data points may be recorded at consistent intervals or over a set of period of time, rather than just recording the data points intermittently or randomly. Okay, some of the main characteristics include, it helps us in short-term forecasting using trend analysis, seasonal or non-seasonal cycle analysis. Then we can find out all the different pulses or the steps, okay, the outliers, all those things we can do using time series analysis. Moving on, we have a set of short notes on, okay, in that coefficient of correlation has come up multiple times. That's why I've put a star over there. The remaining ones only I've seen in spread across different question papers. Okay, so coefficient of correlation, definitely we should plan on studying and going, because there is a high chance it can come up. Okay, so what first question, write short note on random variables. So what is a random variable? It is a variable whose value that results from the measurement of a quantity that is subjected to variations due to chance, right? It doesn't have a single fixed value. Okay, it can take on any set of possible or different values, each with an associated probability, right? It is completely random. That is the thing. Okay, criteria of optimism. Optimism means what? Positivity, right? So it is otherwise known as min-max approach. So in case you are finding a question on min-max approach, this is what you have to write. Okay, the criteria of optimism itself. So in this approach, the decision maker will examine the maximum payoff of all the alternatives that they can choose from, and they will choose the best out of all these. That is, the best in the sense the one which gives the highest or the maximum payoff, it will be chosen. So that is the criteria of optimism. Coefficient of variation, it is the ratio of standard deviation to mean. Okay, correlation coefficient, it describes how two variables are related, right? Related to each other. It describes how one variable moves in relation to another. What are the different types of correlation we know? It could be positively correlated, it could be negatively correlated, there could be no correlation at all, or there could also be a curvilinear, okay, non-linear or curvilinear. Curvilinear relation. Now, what are the few different ways in which we can find the correlation coefficient? We have Cramer's V correlation, Pearson's correlation, which we have already used, right, applied in one of our practical questions. We have rank correlation. So you can write down all those things, different things, and make up for the short note. What is exponential smoothing? It is a rule of thumb technique to smooth the time series data. So exponential smoothing also you can include in when you are writing about time series analysis, right? It is a method of smoothing the time series data using the exponential window function. It is used for short-term forecasting, and it will produce accurate forecast results as well. Okay, what is central limit theorem? It is a statistical theory which states that when there is a large sample size has infinite variances, then the sample will be normally distributed and mean of the samples will be approximately equal to the mean of whole population. So that is central limit theorem. Moving forward, okay, again, these are also a bunch of short note questions, out of which short note on skewness has come up multiple times. Okay, so first let us look at what is type 1 and type 2 error. So type 1 and type 2 error comes in the part where we are talking about hypothesis testing. Okay, so these are the two types of errors that could come up while we are testing for hypothesis. So what is it? Okay, so based on our data, we can either choose to accept or reject our null hypothesis, right? And there is a chance that the null hypothesis is actually true, okay, and that the null hypothesis is actually false, correct? So when we accept an actually true null hypothesis, it is correct. When we reject an actually false hypothesis also, it is correct. But when we reject an actually true hypothesis, it leads to type 1 error. And when we accept an actually false hypothesis, it leads to type 2 error. Okay, so that is type 1 and type 2 error. What is quartile deviation? Quartile deviation is the half of the difference between the upper and lower quartile. What is Bayes' theorem? Bayes' theorem is also called as Bayes' rule. It is used for calculating the conditional probabilities of mutually exclusive events. You might remember, right? Probability of A given B. How do we calculate it? It is probability of A union B divided by probability of all the different combinations, where A 1 to n is the set of mutually exclusive events of the sample set and B is another event from the same sample space such that probability of B is greater than 0. Okay, what is skewness? Skewness is the lack of symmetry, right? That it could be positively skewed, negative or negatively skewed, right? Positively skewed means mean is greater than median will be greater than mode. If it is negatively skewed means mean will be less than median will be less than mode. Now, positively skewed means the data will be like this. This is for positive news graph, and negative skewness will be like this. This is for negative skewness. Okay, so that is skewness. What is rank correlation? It is a measure of the degree bit of similarity between two ranking. Okay, rank correlation, right? So two ranking, and is used to assess the degree of relationship between quantitative variables, like sorry, not quantitative, qualitative. Okay, qualitative variables, like for example your beauty and your intelligence, or your beauty and wisdom, like that. For if you want to find out the relationship, we use the rank correlation. What is one-tailed test? One-tailed test is a hypothesis testing test technique. Okay, it is set up to show that the sample mean will be higher or lower than the population mean, but not both. That is, the sample mean of the population could either be high, okay, or be low, but not both. So that is one tail test. Okay, so that is it results from an alternative hypothesis which specifies the direction. Similarly, on the same path, I would also like to add a point on two-tailed test. Okay, so we also have a two-tailed test for hypothesis. Okay, as per the two-tailed test, what we are trying to what you can say establish is that there is a change. Okay, the change could be high or low, doesn't matter, but there will be a change in the parameter. That is for two-tailed test, whereas one-tailed test states that there will either be the mean will either be high or be low, but it will not be both. Okay, that is where we are doing a hypothesis testing. Next is again a set of short note questions, out of which we have had questions on right short note on normal distribution and Poisson distribution have come up the most. Okay, all the others have come up once or twice only. But if you can see over here, here also they have asked about correlation coefficient, especially Pearson's product moment correlation coefficient. We have had previous question was about short note on correlation coefficient alone, right? But over here they are asking us specifically on Pearson's product moment correlation. So let us look at each of these things. So Pascal's distribution, you can think of it as a negative binomial distribution. It states the number of trials that we will need until you get kth number of success. Okay, until kth success. That is Pascal distribution. Then exponential distribution is again it is a continuous probability distribution technique that is concerned with the amount of time until some specific event happens. Like for example, from now until an earthquake happens, how much time is there? That is exponential smooth distribution. And normal distribution, it is an approximation to binomial distribution. There is a detailedly it is given in the textbook also. Poisson distribution also detailed it has been given. It is a discrete probability distribution which is used in cases where there is a chance of any individual event being a success is very small. Like for example, any rare events, like maybe the number of accidents on the road, or maybe number of printing mistakes in the book. Such kinds of events, in order to describe them, we use the Poisson distribution. Okay, and Poisson distributions, what we must understand is that they are always skewed to right. Okay, that is, they will all be positive, having positive skewness. What is regression analysis? It is a statistical method which shows relationship between two or more variables. Okay, it helps to predict the effect of the independent variable on the dependent variable, like for example age and height. Okay, so what is the difference between regression and correlation? Regression tries to establish a relationship as an equation between variables, but correlation tries to find the strength. Okay, correlation tries to find the strength of said relationship. Okay, exhaustive events, they are set of events which are sure bound to happen. Like if at least one of those events will necessarily occur whenever an experiment is performed. It is the union of all these exhaustive events will produce the sample space for that particular experiment as well. Pearson's product moment coefficient, we have already discussed about it. It is a measure of the strength of the linear association between two variables. There are three levels: strong correlation, moderate correlation, small correlation, right, or low correlation. And how the range is set, I have already discussed while we were discussing about how to solve for correlation coefficient between two variables. All right. So with that, we have come to the end of this video. We have discussed around I guess around 3-4 years worth of question papers, and along with assignments as well. So at least these important questions, definitely look and go. All the best for your exams. Whoever is writing, I definitely pray that all of you be able to write it very well and score good marks. So all the best. See you in the next video. Bye bye.